2026 may become the first year of discovering extraterrestrial life. Why say that? Since 2025, after suspected signs of life on K2-E8b and Mars were revealed one after another, scientists have shifted their focus to an even more fundamental question: what should extraterrestrial life actually look like? So scientists used models from chemistry, physics, and biology to simulate possibilities. The results show that real life forms in the universe are far crazier than the little green men in science fiction movies. Flying in the skies are creatures larger than Mount Everest. Running on the ground are gravity hunters fiercer than dinosaurs. And there are bizarre forms right in front of you that you wouldn't even recognize as living beings. Every single one would completely shatter our understanding of life. After all, the Milky Way has over 100 billion planets with vastly different environments. Yet so far, we haven't found definitive evidence of even a single microbe. But just because you haven't seen it doesn't mean it doesn't exist. Based on rigorous scientific data and astrobiological hypotheses, researchers have already inferred what they might look like. On Earth, life originated from water. 4 billion years ago, the first cell was born in the ocean. So our first destination must be a true water world. Hello, Earthlings. I'm Lao Ma. Welcome to TOY 1452b. This planet is only about 100 light-years away from us, and it's slightly larger than Earth. But the craziest part is that water makes up about 30% of its total mass. What does that mean? It has 7,000 times more water than Earth. There is no land here, only an endless ocean. So what do the natives look like? Scientists propose a concept called hydrodynamic evolution. Simply put, no matter who your ancestors were, if you need to swim fast, you'll eventually evolve into a torpedo shape. Just like sharks and dolphins on Earth, different origins but very similar body forms. So surface creatures on this planet are very likely streamlined swimming experts. But the real highlight comes next. Because buoyancy offsets gravity, life here can grow extremely large. Imagine a beast nearly 100 meters long, 3 times larger than our blue whales. To communicate in such a vast ocean, they might have huge biological antennas on their backs, like shark fins, emitting intense flashes of light, a complete light-based language. And with bodies that big, eating fish alone wouldn't be enough. They would evolve more advanced energy charging methods. Their skin would function like solar panels, absorbing stellar energy and converting it into bioelectricity. No need to eat, just bask in sunlight to survive. But if you dare to dive deeper, down tens of kilometers to the ocean floor, there is no light at all. The pressure is hundreds of times that of Earth's Mariana Trench. Any metal submarine would be crushed into a sheet instantly. To survive the pressure, life there can have no bones or cavities. They would be gelatinous, jelly-like masses. Without light, eyes are useless. They are completely blind, relying on vibration detection. Some may even use bioluminescence like anglerfish, setting traps to hunt in the darkness. Think ocean monsters are scary enough? What if I told you some life forms never touch the ground at all, living their entire lives in the clouds? Long ago, scientists predicted this possibility. Let's shift our gaze to a gas giant 1,300 light-years away. The environment is harsh, but the upper atmosphere has suitable temperatures, just strong winds. We'll call the life here atmospheric jellyfish. They have never touched the ground and don't even know it exists. To avoid falling, their bodies evolved into massive hot air balloons filled with hydrogen gas. Their skin is an ultra-thin membrane capable of photosynthesis like plants. To resist cosmic radiation, their bodies emit eerie blue or red light. Most astonishing is their size. On Earth, the largest animals live in the sea. But here, without solid obstacles, these atmospheric jellyfish could theoretically grow as large as an entire city, floating like Mount Everest among the clouds. Imagine a translucent, glowing blue mountain-sized organism slowly drifting over your head. At this point, you might think this is ridiculous, floating in the wind with no land, and that counts as living? But as Carl Sagan once said, the universe may allow forms of existence far beyond our narrow imagination. Humans are often arrogant, instinctively believe life must depend on comfortable environments. But what if what we see as hell, toxic atmospheres, violent storms, actually are warm cradles for them? Perhaps in their eyes, we, living on hard rock, tightly bound by gravity, are the truly impossible monsters. After the sky dwellers, let's look at those crushed to the ground. This is LHS 114b, 49 light-years away. Its gravity is twice that of Earth's. Here, jumping is impossible. Even walking is exhausting. Brutal gravity eliminates all slender creatures. The residents must be short and stocky. To support their weight, they evolved pillar-like legs, 6, 8 legs even, like cranes holding themselves up. Because it's extremely cold, they wear thick armor like bulletproof vests. Their movements are slow, their metabolism sluggish. When motionless, they look like rocks. Honestly, if you landed here in a powered exoskeleton, to them, you'd look like a lightning-fast superhero. Where gravity is too strong, otherwise it's too weak. Welcome to TRAPPIST-1d. Gravity here is only half of Earth's. If the last planet was a world of dwarves, this is paradise for giants. Biology warns us, low gravity plus abundant oxygen equals a monster playground. Trees can grow as tall as 60-story buildings. Predators here can reach twice the size of Earth's dinosaurs. Imagine a 50-meter-tall beast that can swallow a bus whole. Because of their size, they are constantly hungry. Every day they wake up with one thought: eat. This is Jurassic Park on steroids. If you came here, don't think about being the hunter. You wouldn't even fill a tooth gap. Everything we've talked about so far, no matter how strange, is still carbon-based life, flesh and blood beings. But the scientific community has long had a bold hypothesis. Who says life must be made of carbon? On Kepler 62f, about 1,200 light-years away, extreme environments may give birth to a form of existence that completely upends our understanding: silicon-based life. Silicon is a chemical cousin of carbon. Under high temperature and high pressure, silicon can also form complex long-chain structures. These beings may not have flesh at all. They might look like walking crystals or geometrical-shaped rocks. They don't breathe oxygen. Instead, they obtain energy through chemical reactions, consuming rocks and metals. They don't reproduce by giving birth, but grow new offspring the way crystals grow, directly from their own bodies. The most mind-bending part is this: their perception of time may be completely different from ours. A single action for them could take several days to complete. To humans, they would look like a pile of motionless stone statues. But if you sped up time by 10,000 times, you would discover that these stones are engaging in complex communication, wars in reproduction. This leads to a chilling question: does life have to exist on the same channel as ours? All known life on Earth is carbon-based. Carbon molecules are flexible and active, allowing us to run and jump, but also condemning us to fragility and short lifespans. Silicon-based life, though slow, may possess lifespans that are nearly eternal, even on cosmic timescales. If you encountered a creature the size of the solar system, scratching its head might take tens of thousands of years. Within its vast lifespan, a human life might be just a brief flash. It may not even have time to see us clearly before we are born, age, die, and turn to dust. So it's not that they don't exist, perhaps our timescales simply don't align. After seeing so many forms of life, we must return to the question that keeps us awake at night. Where are they? If the Milky Way contains trillions of stars, even if the probability of life is extremely low, the universe should feel as crowded as a busy city. Some say advanced civilizations hide themselves. Others say all civilizations eventually face inevitable destruction. But among all explanations, there is one possibility, the loneliest yet the most romantic, that is rarely mentioned. Maybe we arrived at the wrong time. Computer simulations suggest the most suitable period for life to emerge in the universe may have been 4 billion years ago. If civilizations filled the universe back then what we see today may only be the ruins after past glory. Or perhaps the opposite is true. We arrived too early. Have you ever considered that humans may not be latecomers to the